Hello, so in today's video, we're going to look at a second circle theorem. So yesterday we looked at the circle theorem where the angle in a semicircle is 90 degrees. Today we're going to look at this one. So you may not have actually seen this one before, but this is a one that we're going to need to bear in mind for this high school A-level maths course. So yeah, we're going to assume that AB is perpendicular to OC. So we're going to assume that these this AB and this O to C line here are perpendicular. So that's our assumption. If we call this A to C, so this is C up there, this point there, C, if we call that X, and if we call this B to C length here Y, then it must be true that X equals Y. So that's our that's our circle theorem. So basically it must be true that this side X must be the same length as this side Y essentially. So in other words, AC is equal to B to C. So that's the key circle theorem that we need today. So how are we going to prove this? So the key thing is we've got our setup like this, exactly the same as this here. And what I'm going to draw is I'm going to draw a line going from O to A like this. Now, key point to realize now is that O to A is the radius of this circle because it's literally going from the middle to the circumference. Now, similarly with this here, this is also the radius there, because again, O to the circumference is a radius. Now, let's pull in our 90-degree angle there, and also a 90-degree angle there, because remember, we're assuming that these lines are perpendicular. That's our assumption. So we're going to assume they're perpendicular. Okay, so we've got two right-angled triangles, BOC, with a hypotenuse of R, and this length there of, again, I'll call it Y. So we'll call this one up there Y, we'll call this X there. And then we've got this second one, right angle triangle, this like base of X, this hypotenuse of R. Now, the key thing to note here is that they both share the same length here, O to C. So both of these triangles there and there, these right angle triangles share O to C, this length in the middle there. So what we can do is we can use Pythagoras. So we're going to use Pythagoras' theorem. Now let's start with triangle. So triangle AOC first. Okay, so with triangle AOC, we've got x squared plus OC squared equals the radius squared, this hypotenuse squared. Okay, so that means that x squared is equal to r squared take away OC squared. Okay, so we've got that. Now let's try triangle O or BOC, this second one on the top here. So how about triangle BOC? So let's do the same calculation using Pythagoras. So triangle BOC. So again, Pythagoras, we've got y squared. So again, this right angle triangle here, y squared plus OC squared. So y squared there plus OC squared must be equal to r squared again. Okay, so now make y squared the subject to the formula. So y squared equals r squared minus OC squared. Right, okay, so now let's look at this. So we've got x squared equals r squared minus OC squared. We've got y squared equals r squared minus OC squared. So therefore, it must be true that x squared equals y squared. Now we can square root both sides of this equation. And if we do that, we get that x is equal to y. Now, technically, you could have x equals plus or minus y, because when you square root an algebraic equation with real numbers, with x and y being real numbers, you get positive and negative real numbers. But because x and y are lengths, let's just make this really clear that x and y are both greater than 0 because they're lengths. Lengths can't be negative. Therefore, it must be true that when we square root both sides of this equation, we do get x equals y. So this length is the same as that length, and that is the key circle theorem for today's video, essentially. Yeah, so this x and y length are exactly the same size, given that, provided that you've got a perpendicular line going from AB and O to C. So these lines are perpendicular. If they are perpendicular, then it must be true this x and y are the same size, and the proof is as we did a few minutes ago.